Hi, today I'm going to be showing a project called a GUI for creating shaders. So in this project, what we have done is we wanted to create a graphical user interface in which artists or designers they can edit and create shaders, and these shaders can be loaded in the game. So to enable this, we have done multiple steps. One, each object in the game engine can have a shader specified. So for example, this is the Imrod object I have selected, and as you can see on the right here, the shading technique is called detailed mesh glow tech. So that is the shading technique that we are going to use for this person. And we have a file that maps a shading technique name with a pixel shader name and a vertex shader name. So for example, we have set Imrod as detailed mesh glow tech, and that uses these two vertex shader and pixel shaders. So that is one example. And so let's say for the soldier, we have something called detailed skin soldier tech 2. So detailed skin soldier tech 2. So this is the pixel shader and vertex shader that that object uses. So that's how we have. So currently we have one for the soldier, one for Imrod the monster, and one for the plane. So the plane object uses detail mesh custom tech. This is the plane object. So this is how we define the technique names in Maya, the level editor. And then when we build it, the source code uses these to color the objects. So for example, we have the Imrod using the default diffuse color shader, and the soldiers have a glowy kind of shader, and the ground mesh has another kind of shader. So this is what's currently running. And also we have created a GUI. This is the GUI. This is made in Python. We are using the Tkinter library. It just has simple widgets like buttons and canvases and lines. So we're using this to create a GUI. So let me create one from scratch. I'll show you how to do that. So I just run this module, and we have an empty page. So we have these operations possible. So you can add data members like float 1, float 2, float 3, float 4, and vertex parameters. These are the parameters that each shader gets as part of the pixel shader input. And so we have these data objects, and we can multiply, add, subtract. So basically we can perform some operations on these data members, and we will get resulting data members, and we can set a color accordingly. So the design is actually inspired from Unreal Material Editor. So if you have a look at that, it has pretty much the same flow. So let's go ahead and add a float 3. So you can add each component of the float. So let's say 0, 1, 0. So that's a float 3 that I've created right there. And then to give a basic example, I can just say now, okay, generate a color from this. So this is, in case you missed what I said. So I say add new result color. So a result color, I can set each component of the result color from a different canvas or a different data member. So let's say canvas ID is 0. So I'm using canvas ID 0, and I can set the colors from any component that I want. So let's say X, Y, Z, and Z, because it has only 3 components. So X, Y, Z. So sorry, what happened to that? Okay, so now you can see the color is, it should be fully green. So once you have a result color, you just say generate a shader file from here. So I just select give it a file name, and then so the shader is generated. So let's see how the shader looks like. So it's just this. So how we actually generate a shader file from here is, so this part of code is just copy and paste. This is a template, so we have that. These are just basically the constants and some global variables needed for the shader. And so for each canvas that we create, we create a new variable here in the shader. So float var3 is 010, just the same thing. And then when we generate the color, we assign each component accordingly. So color R is variable 0's X component, variable 0's Y component, so on. So this is the color that we have. So this would actually give us a RG. So this would give us a full green color. let's test this out now. So we have detail mesh glow pixel shader. So this is the current code that we have. So I'm gonna remove it and I'll go from here. This is the code that we have generated right now. So I'll just paste it here. So detail mesh glow pixel shader. Let's see what that affects. Detail mesh glow pixel shader. This affects detail mesh glow tech and detail mesh glow tech. Who's using detail mesh glow tech? Imrod. Yeah, so the Imrod monster that we have, he's using this. So now what we can do is the shader has been updated. Now we have added a feature where we have a nice command here called reload pixel shaders in the PyClient tool. So as soon as we just say click send, the color is updated in runtime. So we don't have to close the program and recompile the shaders. Everything is done behind the scene. So this was a simple example that we saw. So let's do something more complicated. So we can add a vertex parameter, let's say a normal. So this is the pixel shader normal parameters that we get. And we can say vertex parameter world position. Then let's say we can multiply both of them. So let's multiply canvas 1, which is the normals, by canvas 2, which is the position. So now we have a derived data member, which is basically a multiplication of both of these. So let's go ahead and see how this color looks like. So we can again generate a result color. The canvas ID would be 3. And just a note, the fourth parameter basically defines alpha, or the glow of the object. So we always want to keep it 0. So I want to make it 0, which is canvas 0 z component, which is 0. And this could just be x, y, z of this. So that's the result color that we have now. And let's say generate the shader file again. So we have shader file created. Let's see how that looks like. So this is how it is. So var 0 is, if we can check this. So canvas ID 0 is var 0, canvas ID 1 is var 1, so on, and then var 3 is just var 1 multiplied by var 2, and we send the clear again. So now let's try to change something else. The plane, where's the plane? The plane is using detail mesh custom tech, which is custom pixel shader. This. So let's change the custom pixel shader. Okay. This is the new code that we have. Let's copy it, and this is the custom pixel shader. I'm gonna delete whatever is existing, paste the new code, and let's reload and check it out. Ooh, so that gives us totally black. So, well, yeah, that's the way it is. So yeah, because this is, we have no idea what the normals multiplied by the position gives, right? It's always, what we can do is we can just add result color of only the normals, let's say. So the normals are 1, canvas ID 1, 1, 0, z component, and I get the x, y, z component from here. Okay, so this is just the normals. And you generate the shader. Shader is created. So this is the new. So let's use it on glow pixel shader. So glow pixel shader is basically Imrod, I think. Let's check how that looks. Reload the pixel shader. So there you have it. So this is just the normals being shown as colors on Imrod. So basically this is the flow that we have. And let me show one more thing. We can also use textures themselves, right? We can say, 1 second. We can also add the texture. So if we want to just show the texture colors, so these are the texture coordinates that we get in the pixel shader. So this is the diffuse texture color that we have in canvas ID 4. So I can say add the new result color from canvas ID 4. and as usual the alpha has to be 0. So let's have the 0 z component, x, y, z. Okay, so we've got this, and then generate. So this is the source code for that. So as you see, we sample the diffuse map and we get the diffuse color, and that is just the color. So now let me paste it for the plane. This should change the plane object that we have in the code. Reload the pixel shader, and there you have it. So this is the diffuse color. So we can keep going on, and basically this is a tool for the artists or designers to quickly iterate. So these are all the data members that we have, and you can do any kind of operations on them, and then finally generate a result color and use it to create a shader. So that's that. Thank you for listening.